All right, so letter A says, show that the equation cosine of 2x is equal to sine x can be written in the form 2 sine squared x plus sine x minus 1 equals 0. So we're working with this quantity right now, and we're rewriting it as an equivalent quantity over here. So I have a cosine of 2x. He's going to be a double angle formula. I'm going to want to find the double angle formula rewrite that introduces a sine squared x, since he is not in the original and he's in the one where I need to rewrite it. So I'm going to choose the formula where we have 1 minus 2 sine squared x equals the sine of x. And I'm going to sort, right? Plus 2 sine squared x plus 2 sine squared x. 1 equals 2 sine squared x plus the sine of x minus 1 minus 1. We now have 2 sine squared x plus the sine of x minus 1 equals 0. And then we can say quote erat demonstratum, QED. Part B, hence solve cosine of 2x equals sine of x, where it's on an interval between negative pi and pi. Okay, I'll show you how to consider an interval where we have a negative angle in just a moment, but first let's solve this equation. So let's use the easy rewrite that we found above. 2 sine squared x plus the sine of x minus 1 equals 0. He looks quadratic, so I'm going to let u equal the sine of x. I'm going to write 2u squared plus u minus 1 equals 0, and I'm going to factor him. All right. I am resubbing back in my sine of x from the u substitution, and I've got the sine of x is equal to 1/2. The sine of x is equal to negative 1. So I'm going to use the unit circle to solve this guy, right? I've got points that look like this. Okay, so sine of x is negative 1. I'm looking for a y coordinate of negative 1 on the unit circle, and that's going to happen right here, okay? So let's consider our weirdo interval, right? It's going from negative pi to pi. So we are super familiar with angles that rotate this way. If we're going from 0 to pi, we're only going from 0 to pi in this direction. However, if we're going from 0 to negative pi, we're going to be going in the opposite direction. So all solutions that occur down here are going to be negative angles. I don't know why I erased that. And all solutions that occur up here are going to be positive angles, okay? Simply given by the nature of the interval. So let's look at what negative angle corresponds to a sine of negative 1 on the unit circle. And that's going to be negative pi over 2. Let's consider the solutions where the sine of x is equal to 1/2. So sine of x is equal to 1/2. I'm going to look on my common trig ratio chart. 1/2, that's going to be pi over 6. So I have a reference angle of pi over 6. Now let's consider the quadrant that it terminates in. I want sine to be positive, so I'm going to select the first and second quadrants. I'm going to eliminate the third and fourth quadrants, which is great because that's where those negative angles are, and I don't need to think about them now anymore. I'm just concerned with the positive rotations in the first and second quadrant. Pi over 6 in the first quadrant will just be a plain old pi over 6. Pi over 6 rotated into the second quadrant will be 5 pi over 6. My solutions are x equals pi over 6 and x equals 5 pi over 6. Let's put them all together. We have x is equal to negative pi over 2. Pi over 6 and 5 pi over 6. The end.